Okay, so the point of this exercise is to get a general idea of where the different brain parts are. Okay, and get a general idea of what parts of the brain we need to know where they are. I'm not asking you to know what they do yet, just where it is. So like this is that we're building a map. And so once we understand what things are, then we're going to expand it out. Okay, this is not based on your grading or on your artistic skills. Folks at home, you understand what we're doing here? Anybody? Okay. So why don't you guys come and grab a piece of dough, any color that you want, and we're gonna separate them out into chunks so we can trade different colors for different people. It matches your nails. Very nice. Okay, so the first thing you want to do is if you want to make a cucumber out of it, okay, then it makes it really easy to break into 4 even chunks. I'm going to do this one into so I can have a little bit bigger brain for you guys. So we want to have about 4 even little balls after you chop it up. Okay. See, that's a really pretty lavender color.
Okay,
it looks good. Okay. So what you want to do is you want to trade one of your colors with the people around you. You can just throw them into this. Yeah.
I was confused. I bought this and I have.
Oh, you have more?
Right here because I want to use them.
If the texture of this is freaking you out, you can use your stuff.
Yeah.
Okay, so thank you. You have 4 different colors there?
I don't know.
No, I mean in your stack right there?
Yes.
Okay, awesome. Cool, thank you. Yeah, this does make your hands feel like a kid.
Yeah.
Yeah, okay, so we need to trade colors. So you need to have 4 different colors.
Yeah.
And I'll make some green ones here. Yeah. I got some white up here. We'll have some extra greens. Extra green. Excellent. You're purple? Yep. Oh, you got clear. Okay, clear. So if this were a high school classroom, these would be being thrown liberally about the classroom. Yeah.
I need to trade one of them.
What color do you want?
Green.
Green? Okay. Can't pitch it, I won't do it. You're always welcome to throw it at me though. Like a ninja, I can catch.
But it's just,
Yeah.
we just need 4 different colors.
Yeah, just 4 different colors, yeah. Yeah, that's the salt.
Yeah.
It's just lotion. It'll be fine.
Looks like the kids are teaching.
I feel briny like a child. Okay. So I don't care what colors or what colors you do. So I've got 2, 3, 4. I've got my 4 colors here. The rest is just black. Okay, so I'm going to make mine a little bit bigger than you guys. Okay, so there's our kind of model here, right? So what we're going to start out with is we're going to start out with a spinal cord. Okay, so choose a color for your spinal cord. Don't care. Okay, so what you want to do for the spinal cord, you're going to kind of roll it out. Okay, try to picture a spinal cord in your head. Okay.
Like a whole blob of it?
Yeah, a whole blob. Okay, so on the bottom, so I've got the whole blob rolled out there. Okay, I'm going to put a groove down it. So when we look at the pictures tomorrow, this is the dorsal surface of your spine. Okay, this is going to be the dorsal surface of the spine. So we're going to be building the brain like, it's going to be sitting like this on the table. Yeah, okay. Okay, so on the dorsal surface, there's a little bit of a groove. Okay, so if you ever decide to have a baby in your life, they stick the needle for the epidural right by this groove. So each of the vertebrae along here are controlled the nerves that come out. So this is the dorsal surface. Okay, so the top part of this spinal cord, we're going to flatten out a little bit. And we're going to kind of make it kind of like a triangle shape. Okay, so this becomes our medulla. I wish I had. Can I borrow a piece of paper?
Yeah, you want it lined?
Mine to be fine. Yeah, no, it's fine. I like the fringe. So the last time that I did this, I actually stuck it on the whiteboard, but I realized that that wouldn't work with the camera. So that's why I had to change kind of what I was doing here. See if there is a marker in here. There's a pencil. Okay. Oh, it's backwards. It's like inverted.
You might be able to turn like the zoom. Like sometimes it'll invert.
Mirror. It's on mirror. Wow, that's brilliant. So smart. Okay, I'll write this even bigger. So why did I make the medulla out of a part of my spine? Just one. Why did I make the medulla out of the spine? Come on, disembodied voices at home. Why is the medulla a part of the spine? Somebody here? It connects to it. The medulla is literally just like the spinal cord. So the medulla is, I'm going to draw my groove all the way up to the medulla. Okay? Draw. Make. Okay? So my medulla goes right up there. You have to have extra mass, but yes, I do. Okay. Kid size. Oh, that would be entertaining. I've got masks in my bag, and there's masks up here. Blink. Blink. This is pretty sleazy. Don't tell her I did this. I don't want to give all my pink, so I'm just going to make a new pink one. It's a little bit lighter pink than the other one. So any second now. Well, I could have just mixed green and pink together. Yeah, that's just really lame pink. Is what she's going to get. Okay, what does the medulla do? Oh, we don't really care about what things do we? Yeah. Okay. Okay, so the medulla is this bottom part of the spine. Okay, and the medulla basically controls reflexes, basic reflexes. Okay. So take a different color now, and we're going to take a kind of a relatively small ball. of a different color. I chose one about this big, so proportional to the other one. Okay. And so this little small ball is, we're going to try to shape it like kind of a trapezoid. Kind of shape it like this. And the really important part on this thing is, trying to figure out how would I do that? I want to make lines going across it. So I want to make lines going across it this way. So medulla, you have the line going straight down. In this part right here, it's called the pons. I'm going to sit right on top of the medulla. And which way do the lines go? Horizontal, side to side. Okay. And so okay. So there's structures in the pons. There's structures in the pons that regulate consciousness, being alert and awake. And there's fibers that go back and forth. There's lateral fibers that go back and forth across. Okay, there's lateral fibers that go back and forth across. So whatever color you use for the pons, I have a little chunk of it left. I'm going to break it into 2 equal pieces. And we're going to make the cerebellums. These are, make them into perfect round little balls. Okay, and then we're going to kind of flatten them out. There's your choice right there.
Ooh.
Okay, so we're going to flatten them out. Okay, and then fold them over. Kind of make like tacos out of them. But they're round. And they're going to go on either side of our pons.
Oh, you get all of them.
Yeah, I'll take all 4.
Oh.
So to go with your kid's mask, we've got kids' toys.
I don't know why I didn't notice that they were kids' masks.
Why is this not covering the edges of my mouth?
I was like, it has a design, I want it, but they don't fit.
All right. So the cerebellum are these 2 big chunks on either side. We have ours on either side there. So you got to make a spinal cord, make a stick. Okay. So cerebellum is attached to the pons and attached to the medulla, right here at the bottom of the brain. Goes down the spinal cord. Cerebellum is attached where the cross fibers go across. That's why it's the same color. Cerebellum, cross fibers, medulla, straight up and down. Okay? You can see what we're doing. Okay. Okay, so now, whatever the next color is, we're going to make a heart. Mine about this big, probably about 1/3 of the ball. I love the texture, it's just so fun. It's gonna get nice and purple. Well, you got your blue really good in blue.
Yeah,
How'd you do that?
I didn't do anything.
Did you give it extra love and massage heats?
I just rolled around.
Oh, okay. Well, it's very blue. Good job. I'm the kid that always has gray Play-Doh. You know, like it all ends up in one tub and it's all gray. Like the stuff that we made 2 years ago, still in my office. In cognitive, you'll see it tomorrow if you're in that class too. But that it's all like a puke green color, just like a dark, nasty green. Okay, cool. So now, I'm gonna create this. I'm gonna make a heart. Okay, this is my thalamus. Okay, so it's shaped like a heart. My spinal cord is way too big proportional to the rest of my brain. Give me a second. I'll leave my medulla intact. That's much better. Okay. So the thalamus is shaped like a heart. It's actually called the bridal pillow. The thalamus means. Okay, so look at where we put it. It sits on top of the pons, and it connects the spine, pons, to the thalamus. The thalamus also connects the medulla, and if you kind of pay attention to this, notice how the angles of the heart line up with the cerebellum. See how that kind of lines up? And also pay attention to the fact that it's crossing. Information comes down through the thalamus, comes up through the thalamus. All right. Okay, this is actually looking better than I thought it would. Okay. So now we're going to create two long skinny sticks, and we're going to start getting into 3 dimensions. Can we handle 3 dimensions? Good, good. Okay, so I'm going to make a pencil here out of my Play-Doh.
What was the heart?
Thalamus. It's shaped, when we look at the real pictures before we start playing with the brains again tomorrow, you can start to see exactly what we're doing. But the reason I want to do this first, I want you to get a general layout of where things are and how things are connected together. Okay. So I'm going to make 2 sticks about the same size. They should be the same size. Okay, these 2 sticks are going to become our hippocampus. Okay, so but before we can put our hippocampus in, before we can put the memory in, that's what hippocampus is for, we have to build what's called the basal ganglia. So the basal ganglia, there's 3 neurons in there, 3, okay? I'm not going to make you remember exactly which one is which because it's a caudate, putamen, and globus pallidus. But these 3 nuclei surround the thalamus, and they initiate movement. So they initiate movement. So the basal ganglia initiate movement. This is where when someone is on the influence of amphetamines, they have the repetitive tic. That's because of inability to suppress basal ganglia reactions. You can see someone that has that tic. Okay, so we're gonna make 6 small balls. Okay. Out of this stuff. 6. There's 3 nuclei that we're going to put on here. 3 on each side. So, and the reason why they're cylindrical is important. A, because it's really fun making balls with clay. It's very satisfying. I'm waiting for the art teacher to come in. I get excited that we're making art in an art building. So just as we're making these, Michael Fox had his globus pallidus removed. So Michael Fox has Parkinson's disease, probably from cocaine use. And by taking out the globus pallidus is down by the thalamus, down at the bottom, right here. And the globus pallidus is the one that stops the rapid motion that you have. So it's a part of the brain that releases GABA that stops rapid motion. So like I'm a very twitchy kind of person, and like when I get excited, I don't control myself very well. That's why my clay is always gray. Anyway, so I don't have very good impulse control sometimes. So having good impulse control is the globus pallidus. So why on earth would someone with Parkinson's disease have this removed? Okay, so I just saw that, I don't know if Gerald said that before, but control, whatever that was, involuntary functions. It turns out that if Parkinson's is the inability to move as a result of the inability to activate these dopamine neurons. So if I remove the brakes, he can activate the neurons. But if, I don't know if you, at home you can't really see it, but he basically is constantly wiggling around now. If you see him in life, real life, he's constantly jerking and dippity bopping around. And he said, yeah, he said that one of the really hard things to do is like brush your teeth because it's a lot of really controlled fine motion. So what he does, he just kind of gets his toothbrush in his mouth and just lets it go for it, and just hope for the best. Because that's brushing your teeth is a perfect example of a lot of very fine motor control that it's under automatic. You just, once you start the process, anyway. Okay, so the caudate, I'm going to put up here. Okay, those aren't very symmetrical, but it's okay. And the putamen are at the top. Again, when I show you the real pictures, this will make sense. So again, this is looking at the back of the brain, looking down this way. Okay. We're making a dorsal surface of our brain here right now. So our basal ganglia has got these 3 nuclei. They're all involved with controlling motor behavior. Okay. So now I'm going to take my pencil that I made here. I'm going to stick it down in between the globus pallidus and then stick it back in between the caudate and putamen. All right, that's good. Okay, this is a structure called the hippocampus. All right, the hippocampus, what does it connect to? You really can't see that. Ooh, it's got like salt on it and it's slightly abrasive. That's very uncomfortable feeling. I'll defend next time. The hippocampus, what does that do? Memory. Memory. Okay, so I want you to think about what memory is. Basal ganglia. So the hippocampus is the memory. So I want you to think about where memory is located in your brain. Where memory is located in your brain. It's located around the thalamus. The thalamus is connected to all of your consciousness and your lower brain the lower brain system. Hippocampus is also surrounds the area of the brain that helps control motor movements. Okay, so we control the motor movements with the basal ganglia, and we also have the hippocampus connecting those parts together. So I really want this one keeps popping up, but I want it to be touching the thalamus. All of your senses except smell go into the thalamus. All of your senses except smell go into your thalamus. So everything connects to the thalamus. Everything also connects to the hippocampus. Everything also connects to the basal ganglia. So the reason why these structures are so important, they make up something called your limbic system. Now there's 2 other parts. One of them we can't see because it's called the hypothalamus, which is on the front, which we'll do next time. And the other one is, you can't see the amygdala because that's in the cortex. We'll do that one in a few minutes. But these structures right here are most of your unconscious brain. Okay, so now, very exciting. Cortex. That pink is actually a very good brain pink.
I know, right? I blended it all the way.
Nice. I was actually, that was one of the goals, was to try to make a good brain pink to do this with. So I'm glad that you got that worked. All right. I might have to do some more color experimentation. It's just fun to make this stuff. They use them. They also use food coloring, Jello packets to make the flavors. Then the kids eat it. Okay, so you're gonna, to the next one, you're gonna flatten all the way out. Make it into a big sheet, pizza dough. Okay. You would be surprised, in my developmental class, one of the things, assignments that we're gonna get to is called affordances. Things that allow for stimulation of brains. Play-Doh is a huge affordance for kids because it allows for a tremendous amount of possible stimuli for kids. And so, okay, so now we're going to have a sheet, a nice big sheet, okay? What we're going to build is our cortex. And we can't really develop a really cool cortex like the real brain does. So we're going to do like kind of a metaphor. So what we're going to do is we're going to fold it in half. Okay, and then try to cut it along that half fold. So you have half and half. You could have divided it in balls first if you wanted to, but so what? All right. So we're going to start with the frontal lobe. Now again, this brain is kind of folded flat. Where it's kind of splat. It's actually more like a rat brain than a human brain at this point, the way it's kind of stretched out on the table. Okay, so we're going to build the frontal lobe first. Okay, so we half of the dough ball that you use to make the cortex, we're going to use to the frontal lobe. Okay, so what I'm going to do is you're just going to kind of fold it into some wrinkles and put it on the top of the basal ganglia. Not too scary. Okay, so we're going to take the other chunks. Yeah. Frontal lobe. Yeah. So we're going to cut it in half again. So then you have a quarter of it, I guess. And you're going to stretch, make that one nice and flat. Okay, we're going to kind of fold this up and we're going to make a temporal lobe on the side. I'm sorry, you're supposed to have two of those. So fold this other one in half. Make it up. So take the quarter and make it into two flats. Sorry, I did that right. I got excited. I wanted to make up a little bit. One of the people who did this for a real bio lab assignment actually had all the dough balls weighed out exactly. And so it's like, take 2 grams of this dough and make it all, and it's like, no. Okay, so I'm gonna kind of fold, so I got it in half and I folded it up. I'm gonna put this on the side. Why fold it up? Ridges. So this is very not to scale. I could cheat and use more clay than liquid. Okay, so when we have these bumps are called gyri. Okay. Inside the sulcus is the bump inside the inward part. Gyri on the outside, sulcus on the inside. So I'm creating just a few gyri and sulci here for the brain. So I should have a quarter of my cortex ball left. Okay, I'm going to roll that out nice and flat. And this is going to be the parietal and the occipital lobe. A little bit. Choose it like that. Wrinkle there. Nice and wrinkled. It's so fun. Okay. All right. We got our, okay, we're still working on our lobes here. Got it? Okay. So what we have, very ugly. Anyway, the cortex is terrible. So I want you to kind of think about where the layout of this stuff is. Why is the occipital lobe right in the back, right next to the pons? In the brain, it's right next to the pons. Why would you care about that? Right, so it goes pons, thalamus, occipital lobe. Why would it need to be right there? Are you textured overall? That's it. You can hand sanitizer maybe, clean it up. Okay. So it's so funny. There's a lot of people who become very sensory overwhelmed. No, and I'm very similarly, like if I have an itchy shirt, it's over. I can't, it's not gonna survive. Or if I'm in a room that's too loud, it's very hard for me to focus and pay attention. So I totally am understanding of your finger sensations right now. Okay. You can do it. If you actually keep a ball of clay in your hand and just keep moving it around, you won't know it.
I have a little cousin, he's like 2 years old. When he plays with the slime or like dough, he like actually throws up. He doesn't like
The texture is just sensory overwhelming. Yeah. There was we were looking at, trying to go without divulging too much information about the person, but one of the students in my intro class has a weighted blanket, and she was asking why it works. And it weighs like 40 pounds, and you put it on and it like gives you a hug, and it's shaped like a giant stuffed animal. And it's for people who are sensory overstimulated. You flop it on them, and by causing a heavy constant pressure, it synchronizes a lot of your brain activity, which decreases the overwhelmingness that sensation causes. So the reason why, so you're doing this, the texture, the grit on your hand, you don't notice it because you're activating all the big muscles. So right up here in the parietal lobe, right up on the top up here, that's where you're sensing the grit on your fingers. The grit on your fingers goes to the thalamus and goes to the hippocampus. Hippocampus gives you feedback. When you feel the grit on your fingers, you keep trying to get it off, right? If you keep, so that repetitive motor behavior, and also if you have any little cuts or anything, I have a little cut in my finger here, it stings. Just say no. Ow. Yeah, it hurts. Okay, but again, but you don't notice the grit when you just keep playing with the Play-Doh. Anyway, but so the parietal lobe at the top of the brain it's where all the information comes up to that resolves specifically with the body sensation, where your body is. The temporal lobes are where you hear and where you understand things. What's interesting is the temporal lobes surround the basal ganglia. The frontal lobe, the big part, the biggest part of our brain, the frontal lobe, that's why we used half of the big cortex ball to make it. That frontal lobe is involved with all of our behaviors. So my intro class, we were just talking about the left prefrontal cortex. So my left prefrontal cortex, right here, that part of my brain is in charge of feedback. So one of the students in my intro class today asked, well, where is psychosis in the brain? And the answer is the left prefrontal cortex. A couple years ago, I had a student in my intro class that was in the B classroom, that, you know, the digital theater down there. And she was just, I came out of class and she wasn't in class, and I came out of class after class, and she's sitting on the couch and like there's a tear rolling down her eye, and she goes, I saw a bird and it was beautiful and it filled me with joy. And I'm like, uh-oh. And I'm like, okay, are we on drugs? Or did you take any drugs? Because, you know, you're fine, but just let me know so I know what the proper course. She goes, no, I don't do drugs. And so she was experiencing an acute psychosis. So deep inside here.
Is that normal?
No. No, what happened is sometimes when you get super, super stressed, you dissociate. You step away from yourself. Like you can all feel this if you ever have an exam and you finish the exam, you don't remember anything on the test. That's just, you dissociate for the length of the test. And if you've studied well, you still do well. But if you're unprepared and you dissociate, you're screwed. Anyway, that's why we don't like tests. I like doing this instead. But so when we're looking at, so someone who's experiencing a psychotic event, what's happening is the lower parts of the brain are sending information to the cortex that doesn't match the way the cortex is understanding the situation. So the feedback, I'm going to take the cortex off here for a minute. So I'm going to put this away. There's more feedback going through underneath the cortex than just the basal ganglion and hippocampus. So what I'm going to do is I'm going to take your cortex off. I'm going to smash up the cortex and we're going to redo the cortex. I'm sorry, we spent a lot of time making a wonderful cortex, but just clay. We can do it again. Okay. So what I'm going to do is I'm going to take two little balls and put them on either side of the basal ganglia. These would be where the temporal lobes are. I'm not going to cheat. I'm going to keep the same amount of clay. Clay on the ground. So folks at home, if you don't have time to play with clay and you're too busy doing other stuff, you can turn in a drawing of this stuff. You can turn in, last year I had students do a creative kind of project where they had to figure out like, what was it? Oh, use an analogy to describe the brain. There's a list of brain parts that you need to know what are where on the assignment. And then so by the end of class on Thursday, when we finish doing this, you'll be able to identify all those parts that are on the assignment. We'll have made them all out of clay by Thursday. Very exciting. Anyway, so this is my amygdala. The amygdala sits on the outside of this basal ganglia, the outside of the hippocampus. There are direct fibers that go between the hippocampus and the amygdala. They're called the fornix. This is where emotional memories come from. So like if you look at the picture of somebody that you care about, the connection tells you that that person has an emotional salience to you. If you lose that emotional salience towards somebody, when you look at them, you don't feel anything. Okay, which also can be a symptom of depression, not the fact you don't love them. So please be careful. Moving on. Okay. So the amygdala is where fear is. Amygdala directly connects also to a spot that's right under the thalamus, right by the pons, called the hypothalamus, which we will make next class we make the front side of the brain. Okay, so hypothalamus is where hormones are. So memory, fear, behavior, all located together. Okay, so now we need some cingulate gyrus. So grab a kind of a medium-sized wad of your former cortex. Kind of make it into a pencil again. Break it into two. Okay, so like the hippocampus, these are going to go on the outside of the basal ganglia. So why am I using the cortex material to make these things? Why am I using the same material that I used for the cortex to make these? That green is really amazing. Sorry. I bought the neon colors. Okay. Why is it made out of the same clay that the cortex is made out of? Yeah. Good. It's called the cingulate cortex, or cingulate gyrus technically, because it's really just a gyre of cortex right along the surface of the basal ganglia. Okay, so if I were to open up the plastic brain here, it would be the section that's right around the basal ganglia, right around the center, right here. Okay, and so notice how it goes from back to front and front to back. And it goes on either side. So we have a right side and a left side. This is where automatic behavior comes from. Automatic behavior. So crying uncontrollably is the right cingulate gyrus. You know, like where the point where you're sobbing, it's not coming down, and you don't care. 3 times, 3 times. But that's the sobbing uncontrollably here. So if I stimulate a part of the cingulate gyrus, yeah, right.
No, it's just gyrus.
Gyrus, yeah. I put cortex up here, but it's cingulate gyrus. All these are in the on the assignment too, all the parts. So if I were to stimulate an area right here, like with transcranial magnetic stimulation, pulse stimulator, you would just feel this horrible sense of sadness with no context or reason why. Just that, oh. That's because this gives you the overall feeling of that behavior, and sobbing and crying, that's all here. The left side is much more conscious. That's when you'd say, oh, I'm really mad at you because. So the left side is the rational understanding, the right side is just the emotional effect. And when you have the full blown, okay, so now we need to take a ribbon here. Okay, and so we're going to take a thin pencil. We're going to make what's called a hemispheric commissure. Okay, the word commissure means side to side. You feel the desk because they're really pretty too. Yeah, unpleasant. My hands are seriously drying out, and they're dry before. Oh, my phone will never run me before. So commissure are bundles of axons that go back and forth between the left and right side. Okay, there's 3 primary commissures. Okay, so the first one is talking about the hippocampal commissure, which is right here, the back part of the brain. The second one is the corpus callosum, which is the biggest one, which goes back and forth across the top of, technically it's underneath, so I can do that. There we go. It goes back and forth across the top of the basal ganglia underneath the cingulate gyrus. There we go. That looks good.
What is it called?
Commissures. So this one is called the hippocampal commissure. Okay. The big one at the top is called the corpus callosum. Hippocampal commissure. So there's one more called the anterior commissure, which is in the front, which is underneath here. We can't see it. And that's also called the septum. So the septum goes back and forth across right behind your nose. Not the same septum that people cocaine burn through. That's a different septum. Okay, so the other one connects basically amygdala to amygdala on the front side, which we could draw later. Or we can, when we flip over the brain next class and do the underside. We'll make sure we draw the septum. So what information do you think gets passed back and forth across these commissures? What kind of information gets passed back and forth? I really like the color combination. That's really good. The red, brown, and yellow is just like epic. Okay. What kind of information gets passed across the septum? Come on. It goes from what side to what side? Left to right, right? And where is it connecting to? Right here. Say it again. Okay, so it's sitting on top of the thalamus. So the thalamus, you'll discover the thalamus is pretty much involved with everything in the brain. And it doesn't really do anything, it just connects everything. So there's one set of nuclei in the center that connects everything together. Okay, so that's the thalamus. What are these little sticks that go around the basal ganglia called?
Hippocampus.
Hippocampus. What do they do?
Memory.
Memory. So the hippocampal commissures connect left and right memories together. This is so cool. Everything that happens on your left side is stored in your right hippocampus. Everything that's stored on your right side is stored in your left hippocampus. I have a video of a lady who's had a stroke, right? She lost part of her left hemisphere. So they asked her to draw a flower from memory. So she draws a flower that looks like this. Yeah, just half of it. And then and then she puts the center here and she's looking at it like, yeah, okay, normally we draw a really crappy flower by drawing a really crappy flower like that, but she's only drawing one half because she's only able to remember one half. And when she looks at it, she doesn't see that it's not complete because she only remembers that it has that half. Crazy. Well, we'll show you those videos later. I found this folder with all of them on the network drive. But what you lose, it's inattentional blindness. You lose the ability to focus on the attention of things on the one side versus the other side. And it has a lot to do with the way that these hippocampal commissures go back and forth. So the way the hippocampus connects to the cortex is it connects to everything. These commissures sit on top of the hippocampus and they sit in the bottom of the hippocampus and they connect to everything. So when you form a memory is just, this part of the brain just connects what cells are connected to what cells. In order to find the memory, neurotransmitters are sent out into the cortex to see which cells fire when I activate that connection. Back in the old days, they used to have telephone operators, and they'd have somebody sitting in a room with a bunch of wires. You would spin a little dial, which would send an electric current down the line, which would ring a bell. And when that person would ring the bell, hey, who do you want to connect to? Oh, I want to talk to Mrs. Jones. Fine. She'd take the wire, literally unplug the wire from your house and plug it into Mrs. Jones' wire. You'd spin the thing and it would send a electrical current to her phone, which would cause the bell to ring on her phone. Then you could talk back and forth over the wire. And there literally was a lady, oftentimes a woman, standing there, sitting there, switching it, and then eavesdropping was always the joke. And like when I was a kid in the 70s, they still had a switchboard. And like you could call our town that I grew up in and ask for, hey, can you get me Jimmy's number? Okay, Steve. Like, what are we, 1860 or something? But it literally, so this hippocampus is that switchboard lady. We used to, now you can you actually call the operator anymore? We used to dial O to get the operator. You actually get to someone who sits in a room that can flick switches. I don't think that works anymore. On Verizon, though, if you need to talk to customer service and don't want to deal with menus, hit 0 now. It'll take you right to the person. And then if you have a serious problem, it'll take you to a person on our country, in our continent. I am Thomas. Okay, Thomas, can you send me someone in North Carolina? Anyway, I've had very positive Verizon experiences. Okay, so we have, okay, what are the sides out here? Amygdala, what does it do? Emotions. Okay, fear predominantly, and emotion, and then it connects to the hippocampus through emotional memories. Yeah.
Is it also our desire?
No, because that's actually on the front side. No, so the amygdala's got 4 or 5 basic nuclei. When we get to fear chapter, I'll know that. not there at the second. But it's got 4 or 5 nuclei that all revolve around different aspects of fear. One is involved with found pain, one is involved around association, one of them is involved with facial recognition. But you never forget a face. That's your amygdala. That's also the one where racism comes from, when you fear someone who doesn't look like yourself. That's your amygdala. Sorry, that's what happened. Yeah. But so that's predominantly fear. So that's the opposite of the pleasure centers. So they connect. It's really cool that the basal ganglia that we talked about, the choice of behavior or activating behavior, on the other side of the thalamus, they're directly connected to the pleasure centers. The pleasure centers are on the front side. So as we're kind of looking at the back and the sides of the brain here, we can see that this is all about sensory information and processing information. The front side is all about behavior. So this says, watch out. You know, and which causes, it's really actually kind of neat. When you startle somebody, what do? They jump. So what you do is you tense, you protect your neck, you tense your core, and your hands come up. That's what that is. If you scare babies, boo, ah. It's not funny, but it's funny. It is funny because they all do exactly the same behavior. And if you put your hand in a baby's hand, they hold it hard enough that you can actually pick them up. And that's a cingulate gyrus reflex, where when the baby is nervous, they clench. And so those basic reflexes are more common than just a simple spinal reflex, because the spine is literally just stimulus in, stimulus out. And like your knees, the way your knees and elbows and shoulders work, that's all spine. You know, to walk, it's all spine. There's no much brain involved. It's just flex, reflex, flex, reflex, flex, reflex. And all you have to do is change your posture and your legs will walk. There's some really cool videos with where they sever the spinal cord and then just allow the rat's spine to continue to be working. The rat can walk just fine without it being connected to its brain. Because as long as the spinal nerves are intact, you're good. That's all you need. Yeah, okay. So we've got emotional behavior attached to the amygdala, cingulate gyrus, a whole host of very complicated behaviors attached to this amygdala. One of the book my wife has been listening to while she's been working out, I don't know the name of it, but some lady character, her dad was really abusive to her mom, and this homeless boy next door helped take care of her. His name was Axel. I got to listen to this for a while, and I got sucked into the book. And then she met this really pretty neuroscience guy, and then fell in love, and then he started becoming abusive. Terrible. And then she won't tell me what happened. She's gonna make me have to listen to it myself. And I really don't want to listen to some stupid cheesy romance book, but I need to know. Anyway, so, but why would someone become abusive? That was a long story to get that, but okay. Why would someone become abusive? Maybe like what he's saying with their hands. Well, their cingulate gyrus reacts to stress with violence. Not everybody reacts to stress with violence, but some people cingulate gyrus either A, learn that's how you react to stress, or maybe biologically, that's how they react to stress. Look at different breeds of dogs. That's a really good example for this. Like a Chihuahua, its first line of defense is to rush and attack. Have anybody told them that they're little dogs? No, evidently not. But I've been only bitten by about 3 dogs in my life, and 2 of them have been Chihuahuas. I speak dog. I understand dog. And this Chihuahua little sucker snuck up on me and bit me. The other one was a little Boston Terrier, but I deserved it because I was. And I don't mean playing like Australian cattle dogs. I was playing with one and it bit me, but I was playing with it, and that's what they do. They nip you in the back of your ankles. They go for the Achilles. It's kind of cool. Anyway, it was very. He was at the barbershop. It was very cute. Okay. So this is where your breeds of dogs come in. Like our friends of ours, just their Labradoodle just had 12 puppies. Goody. And of course, they're probably going to sell them and make a fortune because they're those kind of people that everything happens to them, they seem to make more money on it. One of them is kind of funky that came out. We got dibs on the funky one for free. Yeah. Come on. Okay. And so the thing about the funky ones, sometimes they get Labradoodle, sometimes they get Doodle Labs, where they get the genetic personality of the poodle with the hair of the lab, which is the worst of the 2 combinations. We call them the funky doodles. But why breed the Labradoodle?
They want the intelligence of the poodle with the temperament of the lab.
Yeah. Well,
The niceness of the
the niceness of the lab with the hair of the poodle.
Yeah.
Labradors shed 3 or 4 times a year. And they have different length hair that they shed. So it's like a short shedding season, a long shedding season, the medium hair shedding season. And it's pretty much 20. Ours killed a Roomba when we had one. It just clogged it. There's a video of her somewhere on our Instagram, our Google feed. Her just lying like the dog lying spread eagle on the vent, and you just see hair just flying up on the air conditioning vent. I'm like, dog. Anyway. So, but we like labs because a cingulate gyrus, they don't respond with violence to threat. They respond with stoicness to threat. Our neighbors have a pit bull. We love Rio. She's an amazing pit bull. But if another dog attacks her, how does she respond? Very aggressively, because that dog has been bred to attack aggressively. The most sweetest, most wonderful, most friendly dog on the planet until it attacks. Then it's a very strong dog. Doesn't matter if it's super well trained or not. They were bred to fight and to be attack dogs. But like Doberman Pinscher, same thing. Can be the most wonderful, pleasant dog ever, but when it goes to bite you, the cingulate gyrus says bite, not just like a lab has been bred to cingulate gyrus so that it doesn't bite hard. It just it mouths you and slobbers on you. If you want to make a lab your friend, touch its face. Get permission from the owner, but you touch its cheeks and pull on its cheeks a little bit. That's how they play with each other. And that's a way of saying, hey lab, let's play, let's be friends. Yeah, anyway, okay, so think of all the cortex on top of this again, okay? All the cortex on top of this. We've got our cerebellum down at the bottom, coordinating movement, our pons regulating consciousness, all connected to the medulla, which is connecting the body to the spinal cord, okay? All right, so if you have, I won't be able to unlock my phone. Hey Google, where are you? There you are. It's done. Hey Google, where are you? I can see you, but you won't do it. My other one would go, here I am. But okay, so I want you to take a picture of this thing. Because what are we gonna do? We're gonna take it apart. Okay, we're gonna put our dough back, and I'm sure with the amount of salt in this, that it is completely germ-free. I don't think that any virus could possibly live in this. Okay, so if you could put it back into the color wads of close to which it came, and you know, you mix them up a little bit, but not too bad. Right. Sorry about that.
Like my phone is like not working at all.
I'm glad you were resourceful. Okay. I didn't even dawn on me until you said that. I'm like, oh crap, that was very not polite to not to assume that everybody had a phone with them. Yeah, so my Verizon quick story was, I got this one, I sent my old one back, and it's missing in action. Like it never showed up at Verizon. So they wouldn't have my trade-in. And so they gave me $700 for my old phone, so this one was free, basically. But it's missing. So I called the Verizon store where they printed the label, and they gave me a list of 60 tracking numbers of one of them at which it could be. And so I went in with well, I discovered you could do 30 at a time, so I only had to do it twice. And I searched for packages that were missing, and sure enough, there were 2 that were mailed on the same day that I mailed mine that were missing. And so I called the customer support, and I'm like, hey, and I explained everything that I had done, and she goes, okay, give me a minute. Okay, we'll take care of it. Thank you. We assume that it'll be get here somewhere, and they just gave me the credit. In other words, I did my legwork. So, but they sent me right to North Carolina. They didn't bother sending me somewhere else. All right, if you could put the dough balls back in here, we're going to do this again with the other side of the brain, and then we're going to do it kind of like an activity next class where I'm going to actually have you make stuff on demand. You don't have to color everything. That is so pretty. Well done. Oh. The hazards of being back on campus, they're so unseen. This is a perfect brain color. I might have to make more of this. This is what I was going for with paint, so that's really cool.
Yeah, it was a very small amount of.
Just a little bit of pink with the other ones, but I need enough different colors. Okay, let me hit the stop record. Now, folks at home, I'm sorry that was horribly boring for you, but your hands are not very unpleasant feeling right now. Guys have any questions at home?
Yeah, that was really, I really like this, Steve. Good job.
I like this too, and it's more fun if you get to do it.
Yeah, no, but even honestly, watching it was also just as fun. I like it a lot. Great idea.
Look at the calluses on my hand.
Play-Doh problems.
It's serious, like that's the callus. It's like, and someone else needs a new phone. Okay.